In this class, let us learn about how function overloading implements polymorphism. See, the literal meaning of polymorphism. Poly means many, morpha means forms, different forms. See, the thing or an object, it exhibits a different behavior in a different circumstances or according to the background feature. So that is called polymorphism. That is the general meaning of polymorphism. In C++ programming, how do we implement this phenomenon, polymorphism phenomenon? See here, it is a phenomenon in which an object or a thing which exhibits different behavior or different nature in a different circumstances is called polymorphism. Okay, then how to implement polymorphism in C++? There are two ways. One is function overloading. Another thing is operator overloading. But in your syllabus, you have a detailed explanation about function overloading. Just you need to mention operator overloading. See, as per the definition of function overloading, two or more functions or a set of functions having same name with different type of arguments or number of arguments or order of arguments. That is the definition of function overloading. So by knowing the definition, we can say it's a polymorphism. So it is very related to that word. Same name, a set of functions, all functions having same name. When you see the function names, yeah, they are all same, but they are performing different operations. They are performing a same kind of operation on different object. That is depends on the number of arguments or type of arguments. See, as per the definition, a set of functions having same name and perform same kind of operations on different categories of arguments. See, if you consider volume of cone, volume of cylinder, volume of cuboid, so all function names are volume and the thing or the task is volume. We are going to calculate volume. In all function definition, we are calculating volumes, but in each function definition, we are going to calculate a different polygon volume. That is the thing we had written here. Same kind of operation. Kind of operation means volume. Or in all functions, the operation is volume only. We are calculating volume, but on different categories of arguments. So what type of arguments we are passing, based on that it chooses which polygon volume it has to calculate. Understood? In this example, I have taken only two functions to make you understand easily. I have taken the same example. Int area, void, return type specifier is void, and I'm going to calculate area square. So then here two arguments, area of rectangle. So when you see, the name of function is area and it's going to calculate area only on different polygons. That is depends on the type of argument. So that compiler easily identify which function it has to execute for which function call. Are you understanding? So in this way we can achieve polymorphism. So in this example, there are two functions in the set. Let us consider this is a set, and this set having two functions, and that is calculating area of two different polygons. One is square and one is rectangle. That is, a function name is same. Both functions having same name, area, and kind of operation is same. What kind of operation they are performing? Area only, but on different objects. One is area of square, another one is area of rectangle. Okay. Therefore, and these functions are differentiated by number of arguments. So, how they are differentiated? Number of arguments. So, though the name of function is same, but they choose different functions depends upon the type of arguments. In this way, we can achieve polymorphism. If the function call would be like this, for this function definition, the function call is like this: area. I'll pass 5 semicolon. And area, if I pass 4, 6. So when you see this, area, function name is same here. Both functions having same name. By seeing number of arguments, it chooses a particular function, which function it has to call. And it matches with this, and this matches with this function. So in this way, we can achieve polymorphism. So just I'll explain operator overloading, you need not to write in the exam. Operator overloading is not included in your syllabus. I'll give the superficial explanation on that. It is possible to overload a same operator. Only few operators we can overload. So what are those? We can overload plus operator, insertion operator, extraction operator. Okay. So let us consider plus operator. We have to write some code in order to overload a plus operator. Overloading means the same operator. Okay. In case of operator overloading, the same operator, it shows different operation. Depends upon the argument what it received. For example, when you add two numbers, for example, two integers, 4 plus 5, the plus operator, it adds these two numbers. Because what are the type of arguments here? Numbers, integers. So when this operator comes between numbers, it performs addition operator. If I overload this operator, okay, now you leave how to overload that operator. There is a code for overloading. Let us assume we have already overloaded. We have written that code and we overloaded that operator. Now, how to write that? If I write C++ double quotes, it's a string, plus, it's an operator, overloaded operator, and program. So then it returns C++ program. So what happens here? The same plus operator, if it comes between two strings, okay, it concatenates these two strings, it joins these two strings. Okay, because we have given extra feature to this plus operator. If the same operator you use with integers 4 plus 5, then it returns a sum. Okay, the same operator, it gives sum here. Here the same operator joins two strings. How? Depends on the type of arguments on which it operates. That is operator overloading. Okay, now just to make you understand, I explained. This is enough for the exam point of view. Okay, they'll ask for 5 mark how function overloading implements polymorphism. You can write this much. Thank you.